All right, this is Unit 4, Lesson 1, Part 2. We're going to do, as it says, a factoring refresher so that we can get all the factoring stuff down so that we can move on to the later lessons where we're going to be applying this factoring stuff into more quadratic lessons. So it says right here, quadratic equations can be solved by factoring, which is the next step we're going to do after we brush up on our factoring skills. So there are different sets that are different strategies that you're going to want to use. So I'll kind of talk you through when you would want to use each one. So set 1 is greatest common factor, or GCF. This is actually something you want to look for every single time. So any of these other sets, we're going to begin by just checking real quick, like, hey, is there anything that divides into all of these items that I could factor out? So we're going to start with number 1. If you look between 12k and negative 18, they are both multiples of 6. There aren't any shared variables, so just the 6 is a GCF. So it works like this. You put it out front, kind of like undistributing a 6. So if we undistribute that 6, then you have parentheses right here, and then it's like, all right, if I were to divide or undistribute that 6, what would be left over? And if you divide this by 6, you are left with a 2k minus, and then if you divide this by 6, you're left with 3. And then always do a quick double check that there's nothing left here that they share. 2k and 3 don't have anything in common, so that means we got the greatest common factor. So that's your answer. That's all that you do, because this doesn't factor down anymore. Let's do the same thing for number 3. So we've got 3 different items here. So 14, 35, and 7. The largest thing you can take out there is a 7. They're all multiples of 7. And then we have an m to the 6th, m to the 3rd, m to the 2nd. So there are 2 copies of m that they all have at least 2 copies. So m squared would be part of a GCF as well. And then same thing we did with number 1, we're gonna kind of undistribute that 7m squared. So divide this by 7, we have 2. And then if you divide out 2 of the copies of m, we are left with m to the 4th. Minus, and then 35 divided by 7 is 5. And if I divide out 2 of those 3 copies, I have just an m left over. Minus, and then here's where people get thrown off. They see this is 7m squared, this is 7m squared, so they say there's nothing left. That's not true, because if you divide something by itself, what you are actually left with is 1. So make sure that you always have that left behind. So that's our first set. So the next set, we've got a little reminder right here. When you are factoring, and I've just said this before, but just a little reminder, always look for a GCF first. So that's going to continue to apply as we move through the rest of this worksheet. All right, so next set, trinomials, where they're x squared plus bx plus c, and a is 1. So there's no leading term here, no 2x squared or 3x squared. So we start with number 5. Remember, always look for a GCF first. So is there anything that all 3 of these have in common? And there's not. So then we just go right into factoring. So factoring is the reverse of foiling. So I want you guys to think, like, all right, there's going to be 2 binomials here. Start with the first. So if you think of the first for FOIL, x squared must have been this times this. So x squared was x times x. So if you think of foiling this back out, you know that would be true. And then the last term is 45. So this times this has to give us 45. But the important part is that our middle term ends up being 14x. So when I multiply these 2 things together, I should get 45. But the trick is when I add this term and this term, I have to get 14. So we are looking for 2 numbers that would multiply and give us 45 and add and give us 14. And that would be 9 and 5, because 9 times 5 is 45, 9 plus 5 is 14. So we put a 9 right here, put a 5 right here, and you can always check your answer, because if you FOIL this back out and simplify everything up, it'll land right back here. So you'd have x times x is x squared, x times 5 is 5x, 9 times x is 9x, and those combine up to 14x, and then last, 9 times 5 is 45. Number 7, look through for a GCF. There's nothing that all 3 of these items share, and since this is just a c squared, I know that when I set up my reverse foiling, there's going to be a c here and a c here to multiply and give me the c squared. And then I'm looking for the same pattern I just did with number 5. These 2 numbers right here, they're supposed to multiply to a negative 48, but then when I combine them, I'm supposed to get positive 2. So negative 48 means one of these is positive, one of these is negative. And to multiply to 48 and add to 2, it would be a positive 8 and a negative 6. And again, FOIL that back out, prove to yourself that you do get right back here. Number 9, no GCF. Make sure you're looking every time. So we start with our empty binomial. A squared would be a times a. These two numbers are supposed to multiply to 36 and they're supposed to add to 12. So that would be +6 and +6. And always pay attention to the signs too. Both of these are positive, so we know both of these will be positive. And this, since they're the exact same, if you want, you could write this as a + 6 squared. And recognizing that will actually help us a couple lessons down the road. All right, one more of these. Always look for a GCF first. If you look, all three of these terms are even. So that means that there's a 2 that we could factor out. So factor out a 2 and then undistribute. So this would be a k squared. Divide out a 2 here, we have -8k. Divide out an 8 here, we have -20. And then you look back at this and it still fits this pattern right here, which means we're still gonna factor it down further. So keep the 2 out front, make sure that 2 is always there. And then this trinomial, we can factor it down further like this. So k squared, just like the previous 3 problems, would be k times k, and we want to multiply to -20, add to -8. So that would be a -10 and a +2. If you multiply those numbers, you get -20. If you combine them, you get -8. All right, moving on to our next set. Trinomials again, but where there actually is a term here, an a, that doesn't get divided out. So 13, for example, there's a 2 here, but you can't divide everything by 2. So I'm going to teach you guys a strategy. It's called the slide and divide. So here's how it works. You take this 2 right here, and you slide it down to the end, and you multiply it by the 18. So we no longer write the 2 in this first spot. The middle term stays the exact same. We slid this 2 down and multiplied it by the 18. So 2 times 18 is 36. So that's your very first step. Then you factor that. And you factor this one the same way that you factored these. So we'll do that really quick. So we know this is going to be x times x. And then multiplying to 36 and adding to -15 would be 2 negatives. And multiplying to 36, adding to 15 would be 12 and 3. 12 times 3 is 36, and you combine them, you get 15. So that's not the answer, because we did the slide, we still have to do the divide step. So the number that we started with right here, this 2, we're going to take that 2 and divide this by 2 and divide this by 2. So we're almost done. There's one more step that we need to complete. So if they reduce, like this one does, 12 over 2 reduces down to 6, so you just write it as 6. That's one of our factors. And then if it does not reduce, like this, 3 over 2 doesn't reduce, so you take the 2 and you slide it back in front of the x. So the 2 slides back in front of the x, and then the -3 stays right where it is. So this is your answer for number 13. And since these are a little trickier to see, I might recommend just, foil it back out, confirm to yourself that you do in fact get this. So I'll show you. X times 2x is 2x squared. Outside, we have a -3x and a -12x. That combines up to a -15x. And the last is -6 times -3, and that is 18. All right, so we've got a couple more of these. So 15, remember, look for a GCF first. We don't have one. They're not all divisible by 3. So we're going to do the slide and divide. So we're going to take that 3 from the left and slide it over, multiply it by the -40. So this is now h squared, middle term stays the same, and -40 times 3 is -120. So kind of bigger numbers, you might want to play around on a calculator. So factor it like normal. We have h times h gives us h squared. And then what we're looking for are 2 values that multiply to a -120 and add to a -19. So we know it's going to be 1 negative, 1 positive. And again, if you play around on a calculator, it ends up being a -24 and a +5. They multiply to -120, they combine to a -19. So remember, we're not done with the slide and divide. We have to take this 3 that we started with right here, divide this number by 3, divide this number by 3. If it divides evenly like this, 24 over 3 is 8, so we're just going to write it as 8. If it does not divide or reduce, remember this denominator slides back. So the 3 slides back in front of the h, and the 5 stays right there. So we're going to do 17 and 19 as well, because this is probably the trickiest method that we've got. So number 17, look for a GCF. 6, 5, and 21 don't share anything. So the 6 is going to slide to the end and multiply. So this is now just a y squared. Middle term stays the same, and we multiply -21 times 6, and we end up with a -126. So again, big numbers, you might need to kind of play around and see like what's 126 divisible by, and that way you can figure out what this factors down to. So factor it down, y squared is y times y. And then if you play around with the factors, what you end up with is negative 14 and positive 9. So if you multiply them, you get negative 126. When you combine them, you get negative 5. So that is kind of our intermediate step. Remember, our final step is to take the 6 and divide. So this one is a little tricky. It actually requires an extra step because these reduce, but they don't divide evenly. So the 14 over 6 reduces down to 7 over 3. And the 9 over 6 reduces down to 3 over 2. We can't leave it like that. In this method, we can't leave the fractions. So we still do this like slide back that we did up here. We just had to reduce these first. So the 3 slides back and we get 3y minus 7. And then this 2 slides back and we get 2y plus 3. Remember, like I've been saying, if you doubt yourself or if you doubt me, FOIL this back out and I promise you'll land right back here. You wouldn't have if you had slid the 6 right here. That wouldn't be right. You have to make sure that they're reduced first. All right, last one in this set. 9, 12, 4, they don't share anything in common. So we're gonna slide the 9 to the end and multiply it by the 4. So this is an x squared. Middle term stays the same, and then we have 4 times 9, which is 36. So this is a nice, easy one to factor. We had a really similar one on the front page. So x squared, we do x times x. And then multiplying to positive 36, adding to negative 12, that would be a negative 6 and a negative 6. So remember, we're not done here. We have to take this 9 that we started with in the beginning and divide these by 9. This comes out pretty similar to 17, where these reduce, but they don't divide evenly. So make sure you do that first. So 6 over 9 reduces down to 2 over 3 for both of them. And you can't leave it like this either. Once it's reduced, then you slide that denominator back to the front. So the 3 slides back in front of the x. We have 3x minus 2, and then another 3x minus 2. So just like a similar one on the front, if you want, you can write it as 3x minus 2 squared. Since it's the exact same copy, it's just multiplied by itself. All right, on to our last set, the difference of squares. So as always in this set, make sure the first thing you're looking for is a GCF. And then after that, we've got this kind of pattern that's gonna follow every time. So these two have nothing in common. We know it's still gonna be 2 sets of parentheses, and it works like this. X squared is still x times x. And then this one's a little bit of a trick because we want these two to multiply together and give us negative 4, but we need there to not be a middle term. And so what that means is that our middle term is gonna cancel out. So really it's like these numbers are gonna multiply to a negative 4 and they're gonna add to 0. And what that is would be a negative 2 and a positive 2. They multiply to negative 4, but when you combine them, you get 0, and that's why there is no middle term. Okay, so this is the factoring. The pattern I want you guys to look for is right here in the name. It's the difference, which means it's subtraction. Notice all of these are subtraction. And squares, meaning once a GCF is out, if you have one, what you're left with is perfect squares. So x squared is a square, and 4 is one of our perfect squares. So let's look at number 23. So look for a GCF. These don't have anything in common. It is the difference. These are both squares. 9 and 25 are squares. X squared and y to the 4th are squareds. A trick you can remember is that if there's an even exponent, it's technically a perfect square because y to the 4th would be y squared times y squared. So that's a perfect square. So we set up this pattern. We know it's going to be our 2 binomials. So start with the 9x squared. I want you to think what would multiply by itself to give us 9x squared, and that would be 3x times 3x. And our pattern is going to be always just like this. You're going to have 1 minus, 1 plus, but other than that, the terms are going to be the exact same. So then 25y to the 4th, again, what multiplies by itself to give you 25y to the 4th? And that would be 5y squared. Sorry, kind of sneaking that in there. 5y squared. So 5 times 5 is 25, y squared times y squared is y to the 4th. And you can look and see if these factor any farther. Like this might be the difference of squares, but it's not. Neither one of these are perfect squares, so it's done. Last one, number 25, look for a GCF first. 72 and 2 are both multiples of 2. So we're going to first divide both of those terms by 2 and then go from there. So before the GCF, this was not a difference of squares because 72 and 2 are not perfect squares. But once I take the GCF out, 36 and 1 technically are perfect squares. So now I can go into my pattern. Remember, the 2 stays here the whole time. Then I have my 2 sets of parentheses. So just like I did up here, 36r to the 6th. This is an even exponent, which means it's technically a perfect square. So think what would multiply by itself to give me 36, and that would be 6 times 6. And then the r to the 6th would be r to the 3rd times r to the 3rd. So you basically just cut that in half, which is why it has to be even. And then follow the pattern, 1 minus 1 plus, and s squared would just be s times s. And that is factored down as far as it can. All right, so those are all 4 of our sets, all of our patterns.